Okay, lesson 7.5, what we're going to do is we're going to be solving special types of linear systems. So if you remember 7.1 to 7.3, what we did is we learned the 3 different ways to solve a linear system. The first way was the graphing method, where we graphed each of the lines and figured out where they crossed, and that was our solution. The second method was substitution, so we got one variable by itself so that it would say x equals this or y equals this, and then I plugged it in. And then lastly, in 7.3, we learned elimination, where we tried to get a positive and a negative of the same number so that they canceled out, and then we solved. So what are we going to do in 7.5 is, what we're going to do in 7.5 is we're going to look at special types. You may say, okay, what do you mean by special? Okay, let's do a little background information. First of all, you don't need to write this down, just follow along with me. When using the graphing method to solve a linear equation, okay, so ask yourself this. When we graphed, how did I know my solution? Okay, well, we put it in y equals mx plus b form. Remember, we graphed each line, and how did I know my solution? Oh, all I did was I figured out where those lines crossed, okay, and that's how I find my solution. But what if you go to graph and your lines that you draw never cross? Would there ever be a solution? No, there's never going to be a solution. What if the lines that you graphed the first one, and then you went to graph the second one, and you realized they're the exact same line, even though that one doesn't really go directly over it, okay? What if they turned out to be the exact same line? How many solutions would I have then? So that's what we're going to go over today is what happens if when I graph it, they're not the exact same? Or what happens if when I graph it, they are the exact same instead of just crossing at one spot and giving me one nice solution? Okay? So there's 3 different line types. We have parallel lines, which are the lines that run side by side and they will never touch. We have the same line where I would graph one line here, and then I would go and I would graph a second line, and it would fall exactly on the same spot, okay? Then, lastly, I would have my lines like I would do in lesson 7.1 where I graphed the first one, okay? And then I graphed the second one, and they had a nice solution right here where they crossed at the first time. Okay, so what I want to do is I want to figure out what type of line it's going to be and how many solutions it's going to have. First of all, let's look at our parallel lines, these first type here. The parallel lines will have no solution. They will never have a solution because if you look at these lines, are they ever going to touch? No. And you say, all right, so does that mean in order to figure this out, I'm going to have to graph every single type of line? No, it does not. We have a wonderful way of finding out, are they going to be parallel lines? Are they going to be the same line? Or do they just intersect at one spot? And how many solutions will they have? Okay? All I've got to do is put the equations in y equals mx plus b form, okay? So, we'll come back over and go over these 3 things right here in just a second, but if they are parallel lines, which means they never touch, they will have no solution. If they turn out to be the exact same line, that means they have infinite solutions. Everywhere this line goes, it touches the other one. So this is a solution here, this is a solution, this is. If you notice, every single place the line goes, it's a solution. And lastly, if the lines just intersect, they touch at one spot, then they will have one solution. Because if you notice, these lines right here, they only cross at one spot. So I only have one option that is a solution. Okay, and so you say, all right, so you're telling me that I can look at equations and know exactly what type of lines they are before I even have to graph them? Yes, that's exactly what I'm saying. And how you do that is all you've got to do is put the lines in slope-intercept form. What slope-intercept form? Y equals mx plus b. Whenever I do that, I don't have to graph anything. I know exactly what type of lines they're going to be. And this is how I know. Because once I put them in y equals mx plus b, if I look at the equations and they have the same slope, that means they have the same number in front of x, or the same m, then I know they're going to be they're going to be parallel lines, and they will have absolutely no solutions. Now, if I put it in y equals mx plus b form, and they're the exact same equation, so I'm talking about, well, let me give you an example of parallel lines. Let me backtrack just a second. So, like, same slope. So if I were to put them in y equals mx plus b, and one of them I got y equals 2x plus 1, and the other one I got y equals 2x plus 5, okay, I know that these are going to be parallel lines because they have the same number in front of x. Now, whenever I get the exact same equation, I know they're going to have infinite solution, because when I graph it, it's going to be the exact same line. So it would be something like y equals 2x plus 3 and y equals 2x plus 3. Once I put it in slope-intercept form, they're the exact same. So they're going to have an infinite amount of solutions, and they're going to be the exact same line when I graph it. Okay? And lastly, if I go to put them in y equals mx plus b form, and one comes out with y equals 5x plus 1, and the other one comes out with y equals 6x plus 2, is there anything the same at all? No. That means I know that they are only going to cross one time. The lines will intersect, and I will only have one solution. Now, the only catch to that is you can have the same y-intercept. So let's say we have y equals 5x plus 1 and y equals 6x plus 1. They're still considered intersecting lines because they don't have the same slope and they don't have the exact same equation. So we call that nothing is the same. Even though these numbers are the same, they technically don't mean anything. Okay? So let's put that into practice. So I have three different types of line. Parallel lines, which means they have the same slope or the same letter or number in front of x, and that means they're going to have no solution at all. They'll never ever touch. Then the second type of line I have is the same line, okay? Those lines will have an infinite amount of solutions, so that means they will have, no matter how far the line goes, it's always a solution, and I can figure that out by putting it in y equals mx plus b form, and they'll be the exact same equation. And then lastly, I have intersecting lines, okay, and they will have one solution because when I put them in y equals mx plus b, nothing is the same. So three types of lines: parallel, same, and intersecting. So let's put that into practice. So they give us the linear equations, and obviously there's always going to be two per thing, and each of these I have to put in y equals mx plus b form to find out. You cannot just go, oh look, they have a 2 in front of x, so I know that's the same slope, and I know they're going to be parallel lines. No, they have to be in y equals mx plus b form. So I have to ask myself, okay, what do I need to do to this equation to get it into y equals mx plus b form? I need to subtract 2x on both sides. And I get y is equal to negative 2x plus 5. Okay, it's in y equals mx plus b form. Let's do that to the second one. Subtract 2x on both sides, and y equals negative 2x plus 1. Okay, so I ask myself, do they have the same slope, or the number in front of x? Yes, they do. Okay, so they could be parallel lines. Let's check out the rest of the equation. Is everything the same? Nope. So I know that these are parallel lines. And how many solutions they have? I realize parallel lines look like this, so I know they're never going to cross, so that means they have no solutions. So I can just write none. All right, let's do the next one. Let's put it in y equals mx plus b form. So I add 2x to both sides, and I get y is equal to 2x plus 3. This next one, I add 4x to both sides, but I still have 2y is equal to 4x plus 6. I still need to divide everything by 2, and I get y is equal to 2x plus 3. What happens there? They are the exact same equation. So what kind of lines are they? They've got parallel, same lines, or intersecting. Same equation means they are same lines. How many solutions will the same line have? An infinite. Because they never separate. They always keep touching. So they're always going to have as many solutions as you can possibly think of. All right, let's do the last one. Subtract 2x on both sides, and I get y is equal to negative 2x plus 4. This one, I subtract 4x on both sides, and I get negative 2y is equal to negative 4x plus 0. Then I divide everything by negative 2, and I get y is equal to 2x plus 0. Okay? Do I have the same slope? No, because one is negative and one is positive. Is the whole equation the same? Nope. So these I know are intersecting lines. Nothing is the same. And how many solutions do intersecting lines have? 1, because they only intersect at one place. Now the biggest mistake people make here is they go, oh, since parallel lines never touch, since intersecting lines, nothing is the same, they have no solution. No, that's not correct. Intersecting lines, since nothing is the same, that means they do touch at one spot and they do have one solution. Okay, so all you got to do is put each equation in y equals mx plus b form, and then you can find out what type of line it is. 3 different types of line. Parallel, which have no solutions. Same lines, which have an infinite amount of solutions. And intersecting line, which has one solution.